Alright, so we're starting chapter 4 this week. Section 4.1 covers probability distributions, and so like always we have some definitions that we need to cover first. First of all, we're going to talk about random variables. So a random variable x, so it's going to be the value x, represents a numeric value associated with each outcome of a probability distribution. A random variable is discrete when it has a finite or countable number of ways of possible outcomes that can be listed. So for example, X being the number of sales calls a person makes in one day. That's a finite number. We're going to have to count the number of sales calls he makes. Versus a random variable that is continuous. So that's when it's uncountable. So for example, the hours spent on a sales call in one day. You really can't count time. Yes, we could say 1 hour, but you can't count time because time is continuous forever and ever and ever. So that's what would make it continuous. So some examples of this. Determine whether it is the random variable x is continuous or discrete, and explain your reasoning. So number 1 says that x is the number of Fortune 500 companies that lost money in the previous year. So again, it's the number of Fortune 500 companies that lost money. This is discrete because we can count it. So it is countable. There's a finite number of them. Then number 2 says let X represent the volume of gasoline in a 21-gallon tank. Well, volume then, similar to time, is not countable. So this is going to be continuous. It's not going to be easy to say I have 1.1 gallons, 1.11 gallon, 1.112 gallons. So as those numbers sort of try to fluctuate, it's very hard to say the exact amount that's in there. So this is continuous. So it is not countable. And so if you think of volume, you can't actually see the change. It's not something that you can really see, the change in volume continuously. So from there, then, we're going to be looking at a discrete probability distribution. So we're going to look at just discrete probability for now. These now are distributions. So we're going to look at it in a little broader term. So this now is a list of each possible value the random variable can be assigned, together with the probability. So we're looking at some options and their probability. So in words, the probability of each value of a discrete random variable is between 0 and 1. And that's what symbolically this means. We're between 0 and 1 for the probability. So in other words, it has to be a decimal between 0 and 1, which is the definition of probability anyway, so that should not be too horrible to remember. Then the sum of all of these probabilities has to equal 1. So when I add up the sum of all of these, because it's all talking about the same problem or the same situation, then it has to equal 1. Can't be more than 1, can't be less than 1. So to construct a distribution probability, discrete probability distribution, we have to look at the outcomes that are possible. We're going to look at all possible outcomes from x1 to x2 all the way out to xn. I know that doesn't make a lot of sense, but once you see it in action, it's not terrible. You're going to find the sums, you're going to find the probability, you're going to check to make sure that it's between 0 and 1 inclusively, and that the sum adds up to 1. So, an industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Each individual was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicates a neutral or neither trait. The results are shown below. Construct a probability distribution for the random variable x, then graph that using a histogram. So the score on the exam was 1 through 5. The frequency, 24 people scored a 1, 33 a 2, 42 a 3. So when I add these up, we ended up with 150 people who took the test, and that's given in the problem as well. And now we're going to find the probability of each of those. Well, we know how to find probability. It's going to be the part over the whole number. So P of 1 is going to equal 24 over 150. P of 2 will equal the 33 over the 150. P of 3 then will equal the 42 over 150. So on and so on and so on. So again, using your calculator, P of 1 is equal to 0.16. P of 2 equals 0.22. P of 3 equals 0.28. P of 4 equals 0.20. And P of 5 equals 0.14. Then the next thing we want to do is make sure that when we add this column, that this sums to 1. And that's a question. So we need to check that in our calculator and make sure that we are getting the right answer. So that would be 0.16 plus 0.22 plus 0.28 plus 0.20 plus 0.14. Add that up. And you want to know whether it equals 1. So it's a question right here. And when you add that up, you do indeed find out that that does equal 1. So to create a histogram, again, not terribly different than what we've done before. Our options here are 1 through 5. Our probability is going to go on this side, so this is going to be your P of x. This is going to be the score. The probability goes from 0.14 being the lowest to 0.28 being the highest. So 0.1, 0.2, 0.3, 1 is 0.16, so about halfway between. P of 2 is 0.22, so a little above the 2. The third box is 0.28, so almost to 3. 0.4 is 20, so we're back down below 3. And then 5 is 0.14, so a little below the 1, the first box. And again, nothing really new here. What's new is that we're putting the options together in a chart that's going to make this distribution better for us. So next example, it says, verify the distribution for the 3-day forecast and the number of days of rain is a probability distribution. So we want to verify that this distribution is indeed a probability distribution. So what two things are we checking? Well, first we're going to check and see whether P of x is between 0 and 1. And yes, you can see all these numbers are between 0 and 1. No negatives, nothing unusual, so that is true. Then the next thing we're going to do is sum the probabilities and see if they equal 1. And that's your question. So 0.216 plus 0.432 plus 0.288 plus 0.064. Add that in your calculator. Check to make sure that it is equal to 1. And in this case, it is equal to 1. So yes, this is a probability distribution. So how about these next two? Are they or are they not probability distribution functions? Well, first, are all of the probabilities between 0 and 1, is P of x less than 1 or greater than 0 or equal to? And that's true. And then the next question, does the sum of all the P of x's equal 1? So we would have 0.28 plus 0.21 plus 0.43 plus 0.15. If we add all of those up, we find out that this is equal to 1.07. So this is not a probability distribution. How about the second one here? Okay. Well, these are written as fractions, so we have to be really careful. Well, again, is my probability between 0 and 1? Well, 1/2 is 0.5, so that's good. 1/4 is 0.25, 1/4. 5/4 then, because my numerator is larger than the denominator, this number is going to be greater than 1. It's 1.25. It's an improper fraction, if you remember that from elementary school. And then the last one, obviously, is negative, which will be less than 1. So this is not a probability distribution. You don't even have to worry about whether it adds to 1 because it's not a probability distribution because of the negative of the number greater than 1. All right. So next, just like with all of the other stuff that we talked about whenever we're doing our statistics, we want to know what the mean is, what the variance is, and what the standard deviation is. So mean, variance, and standard deviation. The mean of a discrete random variable is given by this formula. You're going to take that sum of all of the x's multiplied by P of x. So one more time, if you do order of operations, you're actually going to multiply first. So you're going to multiply x times P of x. And then add. So to find the mean of the following. This is back to our scores that we just looked at on the aggressive inventory test. So literally, you're taking x times P of x. So that would be 1 times 0.16, which is 0.16. This next one will be 2 times 0.22, which is 0.44. 3 times 0.28 is equal to 0.84. 4 times 0.20 is 0.80. And 5 times 0.14 is equal to 0.70. If I add all of these up, Now I'll end up with, so I'm adding this column, I end up with 2.94. Be careful to make sure you're rounding it to the number of decimal places it says to round to. So if you're rounding it to 1 decimal point, it would be 2.9. Make sure you're reading what you need to round to. And if we look at what that means, what's the interpretation for that? Well, it would say then that the average number of people, or the average score for the people who took the test is 2.9. So this is the average. That's what mean means. That's the average score for the 150 people who took the exam. And that should make sense if you look at the way it is. If you go back up to the original problem, remember we had 42 people with a score of 3 and about equal number on either side. A little more between 1 and 3, a little less between 3 and 5. So it would make sense then that my average is 2.9. Okay. Once we find the average then, we can find the discrete, the variance. The variance also has this ugly formula, not very pretty. And then the standard deviation, as always, is the square root of the variance. So it's this ugly formula taking the square root of it. All right, we do need to make sure that we're able to use our calculator correctly on these. So be very careful when you're using your calculator. So if I look at my calculator, most of the chart is done for us. So again, using order of operations, it says to take x minus your mean. So x minus the mean, here is x. To remind us, we just found the mean was 2.9. Actually, it was 2.94 without being rounded. So order of operations says we're going to take the subtraction first, then we're going to square it, then we're going to multiply. So this chart is laid out in just that way. First we're going to subtract, then we're going to square, then we're going to multiply. So the first step then would be 1 minus 2.94, which is equal to 1.94. So let me put that on the other side. So the first one is going to be x minus u, which is equal to 1 minus 2.94, which is equal to negative 1.94. If we verify number 5, although we already have the answers, but if we verify it, number 5 would be to take 5 minus the 2.94, and 5 minus 2.94 is in fact 2.06. And I do expect you to use your calculator on this. The next thing then is it says it's going to take this negative 1.94 and we're going to square it. And that's what will go in the second box. So 1.94 squared is equal to 3.7636. And again, these are all rounded to 4 decimal places, so we're going to keep everything rounded the same. So this would be the 3.7636. And again, if we're verifying the 5th line, that would be 2.06 squared, which again, if you look at your calculator, 2.06 squared And that is, in fact, 4.2436. 4.2436. Then the next thing we're going to do is we're going to take this 3.7636, that's this piece, and we're going to multiply it by the probability. So we're going to multiply that in this case by 0.16. And when I do that, I get 0.602176. Again, on my calculator, that would be 3.7636 times 0.16, and that gives me the 0.602176. Likewise, if I'm verifying number 5 would say take the 4.2436 and square it. And when you square that number, you do indeed get the point. Oh wait, we've already squared. Sorry. I'm going to take that number and multiply it by my p of x, which in this case was the 0.14. And when I multiply the 4.2436 times the 0.14, I do indeed get 1.594,104. So for the sake of time, a lot of this chart was filled out for you, but please go back and verify that you understand where each one of these numbers came from. They're not hard calculations. Please use a calculator and take your time, but the numbers are not hard. Right? We already verified that when I added these up, they did indeed equal 1, which is good. Now I'm going to take this last column and I'm going to add these up. And when I add these up, that is going to give me my variance. So in this case, when I add those up, I get 1.6164. So variance is equal to 1.6164, meaning the square root of that, or the standard deviation, is the square root of 1.6164. Again, on your calculator, just to refresh your memory on how to find all the buttons. It would be the second square root of 1.6164, which is 1.27137, 1.27137. And again, depending on the number of decimal places, you're going to round the support amount. So what this tells me again is if I'm looking at a bell curve, the average number of people, or the average score that the 150 people took was equal to 2.9 with a standard deviation of 1.27. So that 2.9 is in the middle. One standard deviation is 1.27 from it this direction, and negative 1.27 from it in this direction. So that's how much they vary. Remembering that now, because of an empirical rule, 95% of the people are going to score between the mean and plus or minus 2 standard deviations. All right, next we're going to talk about expected value, because the expected value is much like the mean of all of the, for when we did our calculation. So here was the formula for mean. Sum of x times p of x, and expected value is the mean x times p of x summed together. Expected value is what happens when you're playing a lottery game or playing any kind of sort of game where there's money involved. So this says a raffle ticket, or at a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. Find the expected value and interpret its meaning. So we're going to have to look at the x values. And the x in this case has a meaning, and the meaning is how much you're going to gain, how much money you're going to win, how much money you have in your pocket at the end of the game. And p of x is going to be the probability. Well, we know that they sold 1,500 tickets. We know that there is 1 ticket that's worth $500. So the gain here, the net gain, is going to be 500 minus the $2 that you spent on the ticket. So the net gain is $498. Since there's only 1 ticket, that's one winning ticket, then the probability that you're going to get that is 1 out of 1,500. If you win the $250 ticket, then your net gain is going to be $248. Remember, it costs you $2 to play. Again, there's only 1 winning ticket, so this is also a probability of winning of 1 over 1,500. Likewise, with a $150 ticket, that would be a net gain of $148. There's only 1 ticket, so it's $1,500. Next one, there's 1 winning lottery ticket or raffle ticket worth $75. So your net gain would be $73. And again, there's only 1 ticket. Now, the part we have to remember here is this is what happens when you win. So all of these represent winners. What happens when you lose? Well, when you lose, you win 0 money, but it costs you $2 to play, so you actually have a negative $2 gain. You've lost $2. And how many losing tickets are there? Well, we started with 1,500. 4 tickets win, so that means there's 1,496 losing tickets. So your probability of losing is that 1,496 losing tickets divided by the 1,500. And again, this should make some sense to you because your chance of winning is so small, most of the time you're going to lose. So, what's the expected value if you play the game? That's what that's asking you. If you're going to play this game, what do you expect to lose or win? What is the expected value? Well, we're pretty sure we're going to lose, so it would make sense then that the expected value is a loss for us. So let's find out. So the expected value is equal to 498 times 1 over the 1,500. Remember, it's x times p of x plus 248 times 1 over 1,500 plus 148 times 1 over 1,500 plus 73 times 1 over 1,500 plus negative 2 times 1,496 over 1,500. Add those up, and what does it equal? We use our calculator. 498 times 1 divided by 1500. The division sum here. Divided by plus 248 times 1 divided by 1500 plus 148 times 1 divided by 1500 plus 73 times 1 divided by 1500 plus -2 times 1496 divided by 1500. And enter. And my value, my expected value, is negative. And again, that should make sense because more times than not you're going to lose. So my expected value is $1.35. That's the expected value to play the game. So expect to lose, basically, is what that's telling me. All right, and that wraps up section 4.1.